Ladies and gentlemen, this is Program on Constitutional Government, and in our Friday lunchtime series, we've got one more coming up next Friday, which is will be on Homer's Iliad. So, but we got something different for today, and that's Jim Manzi, who's written this excellent book on, which is really a kind of critique, but also an extension of social science, the surprising payoff of trial and error for business, politics, and society. Jim Manzi founded a software company called Applied Predictive Technologies, and he's pioneered the development of experimental methods now used by the world's largest corporations to set prices and pick new products, identify and market to consumers. He's a senior fellow at the Manhattan Institute in New York, so he's with that crowd. And he's contributing editor at National Review, which is pretty much the same crowd. And he's an MIT guy from other end of Massachusetts Avenue, and then he went to the Wharton School at University of Pennsylvania, where he was a Dean's Fellow. Those are his academic honors.
Yes,
but
they are.
This is a successful man in the School of Hard Knocks, Jim Manzi, who will talk to us about his book and the general problems that are raised in his book.
Great.
So, Jim.
Great, thank you very much. Let's see, I was saying a little earlier, a few minutes ago, that I've probably done, I don't know, thousands, literally, of business presentations in my life, but I think, other than one exception, the last time I spoke in an academic setting was 11th grade. So I'm going to do my best, but please be kind with me. And I prepared some slides, because that's what you do in business presentations. And I don't want to kind of try and turn this into a long lecture, but I'll just kind of use those to be efficient about communicating information for 20 or 25 minutes, and then have an open discussion. But even when I'm going through stuff, I assume the right thing to do is just have free, kind of Q&A as we go. Make sense? Can everybody hear me? Okay, great. So I guess first point, our objectives, as I understand it, I want to try and describe why I think controlled experiments matter not only in physical sciences, but also for social sciences. Everything I talk about we built on the basis of two experiences. One is the company APT that Harvey mentioned, which is essentially a software company that provides software that lets very large consumer businesses design and interpret randomized trials and quasi-experiments in order to determine and predict effects of proposed interventions on human behavior in a non-coercive environment. So we have a theory that if we change our prices in the following way, we'll make more money. Let's do a random assignment trial to take, 52 of our 2,000 stores and assign them the treatment and set up control groups and measure the effects and use that to project effects and improve the treatment. And second is a book that I wrote, which came out, the book earlier reference that came out in May, which is really describing a lot of the foundation for why I think that's important and some of the implications that I think it has, but probably is most relevant for this conversation. In that book, I attempted to find and review every published scale randomized field trial ever done in the history of social science in the developed world up through 2008 in the fields of social welfare policy, economics, political science, criminology, and education. And one of the shocking things is I don't think I got them all, but I think I got more than half of them, and there actually aren't that many. Last thing is just kind of maybe spend a minute or two at the very end talking about at least what I think, on a hypothesis basis or a straw model basis, what I think some of the implications of this might be for what I think is probably most interesting to people in the room, which is, a political organization.
I enjoyed your book, although I only read part of it, but you just referred to a number of all the controlled, randomized experiments in those fields. You suggest you might have gotten half of them. I'm just wondering what that number is.
I found about 1,000, and so what I'd say is the upper limit, I think, realistically, of within the boundaries of what I described, which is at scale, well-designed, randomized field trial intervention in an institutional setting in the developed world through 2008. I think there have been no more than a few thousand.
Thank you.
Okay, so strangely, even though we're going to be talking about a business, the essence of what we're going to talk about today is really an epistemological question, right? So there's a great quote from Emerson: "Life is a perpetual series of it's perpetual instruction in cause and effect." Everything we're going to be trying to understand is, can we build causal rules that allow us to predict the effect of intervention X on some outcome Y? And there's a great sort of, the tension here is, I think, the tension between that and this great quote from Copernicus, which is, to know that we know what we know, and to know that we do not know what we do not know, that is real knowledge. And so effectively, as we start to interrogate social science claims, that a specific class of social science claims, which is, if we execute policy X, we can predict reliably the following useful, reliable, and non-obvious outcome. The question is, well, I get your statement that you say you can do that, but how do I know you're right? How do I know your causal rule really is functional? So, you know, when you start when you do a startup, you go down in this long, dark tunnel for a number of years where you pay attention to nothing but your startup. And I did that. And as I came up and had sold part of it and so on, and sort of came up for air, the United States was just about to head into this huge fiscal crisis. And I remember watching TV, which is the first time I'd done that in a long time, and seeing, you know, these very distinguished men with baritone voices saying with great confidence that this is what we should do to address this problem. And this is what's going to happen if we do it. And I remember sitting there thinking, you know, like, and this is why I eventually wrote the book, like, I just spent 10 years trying to figure out, you know, how many Snickers bars ought to go on the shelf at 7-Eleven, and that was really hard, right? I don't believe you really know what you say, right? And so, you know, we're in this situation of crisis, and, you know, you have, you know, Nobel laureates in economics saying, look, the bottom line is, we don't just need stimulus, we need more stimulus. Or another Nobel laureate saying, in fact, we need to spend more right now. It's very straightforward, right? The problem, of course, is you had other guys with Nobel Prizes in economics saying, actually, it's a triumph of hope we're experiencing, that's going to work, right? And in the book, I go through example after example of, you know, will minimum wage laws reduce employment? You have one guy with a Nobel Prize saying yes, one guy saying no, right? And so the question, I think, is, this would be like the night before the Apollo moon launch, right? You have half the guys in the world with Nobel Prizes in physics saying, you know, rockets can't reach the moon. And the other half saying, well, they can, but we need more fuel. And then a bunch of guys saying, there's no moon, right? So why? You know, why do we have this problem in economics and political science and not in physics? And our hero here is Francis Bacon, right? So he figured out 400 years ago the cause, which is essentially, to quote him in translation, we are prone to suppose the existence of more order and regularity in the world than really is there. We build these very complicated multivariate regression models that find patterns, and we convince ourselves that we have not just found correlation, we've held everything else constant or controlled for other variables. And the parameter estimate, which is the coefficient on this factor in this complicated regression-like what I call pattern finding in the book, model, estimates for us the true causal effect. And one of the things that I think, to read Novum Organum, is once you fight your way through the language, which is so crazy, it's astounding when you read through it. I mean, the guy basically lays out the progress of modern science for the next 400 years, right? At a not abstract level either. And, you know, one of the big transitions he either saw or forced, or probably did some of both, was this idea that, the way I'd put it is, the ultimate goal of science is not actually knowledge, it's better engineering, right? For Baconian science, the goal is to develop, although he's very sophisticated about the process of what we would call today basic and applied research and what beliefs scientists have to have and so on. He's very sophisticated about thinking through that. But really, the acid test is, can we predict that if I do X, then Y will happen? Can I predict the effect of my interventions? And he says the problem is, the underlying problem is we are prone to jump to conclusions. We see patterns, say, I get it. My model describes the way the world works. I know what'll happen now if I flip this knob, because I've modeled the device. If I flip this knob, this thing is going to happen over here. And he says, we tend to leap to conclusions, right? So how do we solve that? Well, he proposed a solution, which he called something else, but quickly became called the experimental method, and later the scientific method. And he says this from a closer and purer league between experimental and rational, which is we would call theory building. much may be hoped, which turns out, of course, to be correct, because this is science. So if you think about the simplest idea of science, I build a theory and I run an experiment. And theory and experiment are like inhalation and exhalation out of breathing, right? They are both essential and they, roughly speaking, alternate. Do a theory, run an experiment. I always learn my theory is never perfectly right. That gives me more information. I build more theories and run more experiments. And that's, in the simplest sense, the cycle which creates scientific knowledge. When we think for a moment about social policy areas, economics, political science, social welfare, and so on, people think, this is not news to anyone in that field. They think about it often as, I develop theories and I evaluate those theories. And a theory is like, I don't know, this works in Chile, maybe it'll work here. Some professors thought it up. It seems like, I'm not trying to make fun of it. Often it's very sophisticated theory building, right? But I have an idea, right? And then I evaluate it. And often in sophisticated evaluation circles, you'll think of this concept of gradations of evidence. At the very bottom is kind of basic cross-sectional regression analysis. And then I move to time series analysis. And then I move up to differences in differences analysis. And then I get up to quasi-experiments. And I start to use fancy stuff like Heckman corrections and so on to try and do a better and better and better job of holding things constant. And even if we accept that the sort of scientific gold standard, which is often called piece of evidence, is a controlled experiment, I have theories and a kind of portfolio of evidence to evaluate them. And one of the things that I've observed in businesses is you make a lot more progress if you see the world that way. And in fact, there are different methods for theory building. If I'm coming up with a new business idea, I might stare at Mount Fuji and decide this is a great thing to do in my store. Or I might run a Markov chain Monte Carlo simulation method of building out the elasticities between prices and units for every one of my SKUs, and then run a complicated optimization algorithm on top of it to say this price point by SKU is going to maximize profits. Rather than thinking of looking at Mount Fuji as where I build theories and building these regression models where I evaluate the theory, it's more productive to say, I have competing ways of building theories. I can stare at Mount Fuji, I can build regression models, I can do whatever I want. Then I go out in some stores and I put the dog food out there and the dogs eat it or don't eat it. Right? That's how we test the theory.
But,
right?
but I mean, why do you even need theory with like large data and analytics now, right? Target has 1 million data points on consumer behavior. They run the correlations. Like, it doesn't really matter why we want to price this roll of toilet paper at $1.37, but that's what sells. I mean, for most of the social science stuff, I mean, it's not like there's some universal theory of the price of toilet paper that's going to be good in 100 years. You just need to know in Topeka, Kansas, people are going to pay $1.37 for toilet paper.
So my company stores every transaction at Target that occurs in every Target store and has for the last several years. We store about 20% of every transaction involving cash in the United States, involving transactions of economic goods. Yeah, exactly. That's why I said about. Right?
Well, what's the data size? How many
Well, for
terabytes a
that
day?
database is probably 10 terabytes.
A day?
No, not even close. For a transaction data?
Even for a year or something?
Yeah, I mean, yeah, exactly. It's 10 terabytes probably for a couple years of data. A typical Fortune 100 consumer business, their transaction level data warehouse is about 1 to 10 terabytes, and Target's pretty big. We were holding all of Walmart's. I mean, that's about as big as it gets, and that's less than 100 terabytes, right? So the thing is, I talk about this a lot in the book. We're a big data company. We believe strongly in it. I think big data is part of how you go at this. I assume has everyone heard the term big data? Right, so all it means is essentially, Moore's law is productivity doubles every 18 months for process, right? You double the number of transistors per unit every 24 months. Transistors are getting more powerful, so you double transistor power per unit, processing power per unit cost every 18 months. The only thing in the world that is growing productivity faster than that is storage capacity, right? Which is Kreuger's law, right? Which basically you double the density of storage on a digital storage unit about every 12 months. So what's happening is storage capacity is racing out ahead of processing capacity, and so you're getting these big pools of data that are hard to analyze. That's what big data is. And the problem with thinking that we are deep in the hype phase of the innovation cycle around big data, right? So it's a real thing. There's really productivity advantages created by the access to this data, but inevitably when you're in the hype phase of these analytical technologies, what happens is you're in a dream of universal knowledge. We're just going to build the all-seeing, all-knowing model to grossly exaggerate. And it's just not true. The problem is you can scale up the volume of data, but essentially, to oversimplify, if I have many correlated observations, it doesn't actually give me as much more information as I think it's going to. And it is much easier to, it remains very easy to mistake correlation and causality in spite of the very large data volumes. Just tell you empirically that's true.
Yeah, no, but I'm just saying that from the perspective of target, do they really need a theory, or can correlation just be good enough because by the time you come up and test a theory that, you know, trends have changed and whatever they're trying to sell?
Well, I mean, there's a question of what is the persistence of the phenomenon I'm testing and what is my testing cycle, right? So without wanting to reference individual customers, but Target or customers like Target, I mean, they're going out, say I've got 10,000 stores, so a big question in a store like that is what's called the front table. So when I come into a store, I've got a table with stuff on it, right? So that's prime real estate all the merchants are fighting over. So what they're doing typically is, again, I'm not saying this is Target exactly, but because I can't talk about individual customers, but them or customers like them. What they're doing is, say I've got 1,000 stores, you know, say they've got the table set out, and on Thursday they're going to take 50 randomized stores and give them challenger set A, and 50 randomized stores to get challenger set B. The rest of the, say, you know, 3,000 minus 100 stores are on the standard table sets. That goes out in the stores on Thursday. They're reading the test by Sunday night or Monday morning. They have a Monday afternoon merchants meeting, and they're changing for the next Thursday what the tables are. So you can get inside that cycle very often. You can't
The point is that you don't need a theory for vendor A necessarily under these conditions is better than vendor B, right?
Yeah, you do, and I talk about this a lot in the book, actually, that you do because, for example, at a practical level, and I give this example in the book, Tiffany's is not going to test what would happen if I put National Enquirer at checkout, right? Because that makes a lot of money for Safeway, right? But it wouldn't make me any money at Tiffany's. So the range of tests is, the range of potential tests, pardon me?
You'd be surprised.
Yeah, you never know. Well, actually, believe it or not, I talk about this exact point in the book, which is you need to test some things that you think are crazy, right? So you have a portfolio of tests, some of which you think are crazy. But what I'm trying to say is the range of possible tests is infinite, literally, and as a practical matter, you know, all but infinite. So the strategies and theories are necessary to constrain the universe from all possible tests to tests that are going to generate economic benefit as a portfolio. So yeah, I mean, you're building regressions all the time. I mean, and it's not like the guys aren't idiots, right? It's not like, I mean, they're scatter plotting in Excel. I mean, they're building sophisticated elasticities for price of toilet paper, where they're doing the Bayesian shrinkage and they're really, you know, kind of narrow in as much as they can on what the real price elasticity is, and they're doing the cross-price elasticities. And then you get to a very big matrix, right? And you have to do some pretty heavy algorithmic work to run the price optimization across, you know, say 100,000 cross elasticity. I mean, they're doing all that work. I'll tell you that empirically, when you build those kinds of models and you say, you move from a world of, well, okay, you've convinced me, let's go do it in my stores, to you've convinced me to give you 30 stores for 6 weeks, 100% of the time, you don't actually make more money when you execute the price changes. That what the testing is doing is, in that kind of a case, it's kind of centering the weapon, saying, you know, actually you didn't make more margin, which we thought you were going to do. You did in this category, and you did in these other categories in these kinds of stores, and that's feedback for the theory builders. Okay, sorry about that. So this is sort of one point about experiments have a unique role. They don't replace this other stuff, but they have a unique role. So I'll go through this stuff very quickly. This is very basic, but I think it's useful to get a grounding. So a controlled experiment, as everybody knows, I think, is you hold everything constant, you change one potential cause, and you see if the outcome changes. And so, you know, there's this, do we need to go through this, like how controlled experiments work? Okay, should I skip all this stuff? Okay. So there's this great stuff about what Galileo really did. It's kind of neat. And then,
well, I like this.
So the high-level points are, you know, it's striking to me when I go back and I read the scholastic philosophers. Like when you read Aristotle describe why heavy bodies fall faster than light ones, I mean, he wasn't stupid, right? It's really hard to see, well, you went wrong right there. Like, it's very convincing, right? And the fact is, we have lots of data. We have lots of empirical analysis that most light things do actually fall slower than heavy things. It's because of correlations with what kind of shape they have, and wind resistance is a big deal, and so on. I think if everyone's honest with themselves, if you close your eyes and imagine yourself standing at the top of a tall building, and in this hand you have a marble, and in that hand you're holding a 1,000-pound ball of super dense plutonium, and you do that, I bet you, if you're honest, you'll imagine this one falling a lot faster. We're wired to think that, right? think about all the economics and social science arguments here. We're like, look, you know, it's intuitive, it's very natural. These guys are, he's Dre's genius in history probably, he says it's right. It's a great argument, and by the way, it seems intuitive. But the problem is, you know, I drop a heavy ball and a light ball and they hit the ground at the same time and you're wrong, right? That's the power of experiments. And, you know, I remember learning about this in high school and it was really cool. And then thinking about it for a while that day and think, you know, I don't believe it. I don't believe that in the 2,000 years from 350, you know, BC to 1600, and all the thousands of people who studied Aristotle, right? I don't believe that there wasn't some guy who said, you know, Giacomo, he says it, heavy stuff falls faster. Give it a big rock and a little rock, and let's see what happens. I guarantee, and in fact, when I researched it, you can find examples of people trying to do this in Alexandria and elsewhere. What Galileo actually did was much more interesting, and that's his actual notebook where he describes the experiment he did, or a copy of the page. He rolled balls down an inclined plane, and the reason he did it was he had to slow them down to be able to measure accurately enough. And he had to use a water clock, which is the most accurate clock he had. And in order to be able to measure times down the plane properly, he had to slow them down and use a water clock to measure things accurately enough, right? It turns out to be trickier to run this experiment than you think it would have to be. I think the important lesson here is that the experimental apparatus in the broad sense is really about holding other factors constant, right? The key thing you have to hold constant is friction. And so what he actually had to do, since he was rolling, not dropping, he carved these you know, indentations in the wood shaped like the ball. And he saturated parchment with oil, and he lined it with it. And the whole point is you're physically controlling other possible causes of the outcome. And so when you start to think about biology, you know, famously James Lind, I mean, you can find examples of things like clinical trials as far back as the biblical book of Daniel. But James Lind is the guy who, you know, discovered that citrus helps prevent scurvy, and that's why British sailors are lions and so on. It's great. You know, I can read his description of what he actually did. He had 12 patients. He divided them into 6 treatment groups of 2 patients each. He kept them in the same place, gave them the same diet. He tried to physically hold, he tried to do what Galileo did, right? He tried to physically hold every possible cause of outcome different, constant that could have caused a difference, and he just gave different treatments to each of them. This is the basic concept of the clinical trial. The real problem with it is, and this is exactly how for hundreds, that was 1747. In most of the 19th century, there were a lot of clinical trials done, and what they tried to do was be in a controlled environment like a hospital, do what Lind did at a more sophisticated level, and they were very smart when you read how they did it. They tried to hold everything constant and just vary treatment. The problem is the body is much more complicated than dropping balls off a tower, rolling them down a plane, and the problem they kept running into is how do I make sure the 2 groups, the treatment group and the control group, really are alike in all respects. I don't understand the body plus environment system well enough to do it. And around 100 years ago, several people hit upon this idea of if I randomly assign people to the test and the control group, I am holding, subject to statistical considerations, everything constant. So that's now kind of central to how you do medicine. Now, it would be natural for me to argue, and many people do this all the time, well, you know, let's have an FDA for social programs, right? The problem is this. When physicists find a physical law, if you think about it, I haven't proved that the law of gravity works at some particular spot in the world by having run the experiment. How do I know the law is indifferent on Pluto than it is here? They assume they're universal, and it works well. Biologists, when I run a vaccine test in Norfolk, Virginia, right, I don't have to say, well, I don't know, does this vaccine injected in the blood work in Dallas and Saskatchewan and Ohio, right? They actually have a concept they call uniform biological response, which is not perfect at all, but it's a reasonable engineering approximation for a lot of drugs. The problem is if I try and apply this to social science, let's say I run a literacy program test, not a vaccine test in Norfolk, Virginia, right? And I prove that this helps 4th graders improve literacy, this program. I can't assume, actually, that it works in urban Dallas and rural Saskatchewan and suburban Ohio, because it's extremely context dependent. So I apologize for the kind of history lesson, but I think it's important to see what's going on in context, right? So I have areas of increasing phenomenological complexity. In physics, the problem was, how can I test our theories? And this is Bacon's insight of, though he really didn't work out this in much detail, but certainly by 150 years ago, we were very explicit about, I run controlled experiments to test theories. When I try and apply it to biology, the question became, well, how do I control? And the solution is randomization. In a world of social behavior, the problem is external validity, right? Even if I run the trial well, how can I generalize results from a randomized field trial, a randomized experiment? This is only contribution that businesses have made, which is the way to ameliorate this problem is lots and lots and lots and lots of tests. If I could run that literacy program in 1,000 school districts, I might find a reasonable engineering approximation that lets me say, oh, I see. In districts where the socioeconomics look like this and the school structure looks like that and the macroeconomics are this for students like this, then we can predict the effect of this intervention. Right? A friend of mine described it as intellectually bankrupt, but practical. So this is kind of the huge issue when we try and think about experimentation here. So I'll talk first about business for 2 or 3 minutes and then about social policy for 2 or 3 minutes and then I'll be done. So I've talked a little bit about APT. It's basically, this is being done at scale. Running randomized trials is being done at scale by, 100 or so of very large companies. I'll tell you a fascinating thing. There have been about 10,000 cumulative randomized experiments run on our platform. If I say, of those tested programs, the ideas, how often did the theory work, which is to create a statistically significant improvement in the metric of interest at positive benefits versus cost? About 10 or 20% of the time. In other words, 80 or 90% of the time the theory is wrong. And it's not just people testing in our environment. Google's talked about 12,000 randomized experiments. They have a 90% failure rate. Microsoft, they'll say 70 to 90%. I actually think it's closer to 90. In other words, in a business, most of your theories are wrong. They don't beat status quo. More generally, I would say here are the following observations I have across 10,000 randomized experiments of attempts to intervene in systems and get people to behave differently. First, 80 or 90% fail. Second, when they do work, they almost always lead to small improvements. You don't solve a problem, you get 1% better, or 1.3% better, or 2.2% better, right? And large advantages are always built by mountains of pebbles. Third, almost all improvements are conditional, right? The example I gave you about Norfolk applies all the time. When I talk to people in business about this, and I say, in social policy areas where let's run the negative income tax experiment and just answer the question once and for all. Let's settle this debate. When we change the effective marginal tax rate for exiting welfare and going to work, what effect does it have on people? It's like saying, I'm going to run a test and say, our price cut's good, right? Well, I don't know. Is it Christmas time or not? What are your competitors doing? There's no such answer. When it comes to social programs, there is no polio vaccine out there waiting to be discovered, right? You're finding small, conditional improvements. At least that's true in business. So I've talked a little bit about, this book on control, where I tried to go through every randomized field trial at scale in the developed world I could, at least in 2008. Strikingly, I talked about one company's doing 10,000, 20,000, et cetera. There are 122 randomized field trials in criminology over about a half a century. There are about 240 experiments in the Handbook of Social Experiments. By best count, there were 3 randomized experiments in all US education through 1980. Through about 2008, less than 100. There have been a lot. And I talk a lot about Russ Whitehurst and the IES and a bunch of enabling legislation, such that we're doing a lot more experiments in education now, but it's a tiny number, et cetera. To go to the earlier question, I count about 1,000. There have been no more than a few thousand, right? One company, Capital One, runs that many randomized experiments in a month. To give you a sense of what it means to scale up randomized experimentation. And the goal is to just rapidly iterate and try lots and lots of things in lots and lots of context. Doing that requires radically lowering the cost per test. Okay, so this is the chart I showed you a second ago with 80 to 90% of things fail. When I look at social interventions now, rather than business interventions, same thing. University of Cambridge, this is 122 experiments done in criminology. 94% failed. The IES, which is the Department of Education's research group, one sequence of experiments in pre-kindergarten education, 1 out of 14 worked, and it was like it created some improvement for 1 year. So this ought to be pretty humbling, in my opinion.
Could you just define what you mean by fail?
Yeah, so as per the prior definition, it means it created statistically significant improvement in the metric category of interest.
Oh,
Okay. So we just go through and you count them. The vast majority of these experiments, when you run a well-structured randomized trial, it just doesn't do anything.
Well, no, wait a second. I mean, if you say have a hypothesis that drinking orange juice makes children happier, and then you find that it doesn't make them happier, would you count that as a failure?
Yes.
Okay. So it's not, because I think, I mean, I'm as an experimental physicist, so I have to
Yeah.
put my hand a little bit. We would say that if you actually know that you can eliminate the possibility that orange juice makes children happier, that's still a certain form of success.
Yeah, the experiment didn't fail, the program failed. Yeah.
I see.
I'm not talking about the failed experiment, no. The experiments had a 100% success rate as experiments.
Yeah.
But what I mean is, the proposed intervention did not achieve the target goal.
I see.
Right, it was just a semantic problem.
Yeah, we just
Yeah.
want to understand what you mean.
Right. Right. Yeah. So, as I was saying,
Just
Uh-huh.
if I might follow up, do you have a percentage for how many of these hypotheses were, how many people went into these experiments with a hypothesis versus how many experiments were conducted without a hypothesis?
I don't. My understanding, for everything I reviewed, I would say virtually 100% went in with a hypothesis. But I just can't state that categorically. You know, this is a very depressing thing to confront, right? And it's very depressing for a business to confront this at first, too. And so, wait a second, we have all these people working in the marketing department and, you know, all these guys doing modeling. Like, well, what are you telling me it's a waste of time? No. What I'm telling you is you are not competing with, I was a moron up till today in how I determined policies, right? You're not competing with, there was no Darwinian process that, you know, did not do a perfect job but settled out to non-idiotic things. In other words, improving versus the status quo is actually very hard. It's extremely hard to develop theories which actually improve versus this kind of crude, rough, non-systematized trial and error process. And, you know, until you confront that, it's going to be very hard to make progress. So this will sound very familiar. When I looked across, and I'll skip this example just because we've got to talk, unless you want to go through it. You want to go through the criminology example? I don't want to take all the time on it. Okay. So here's a good example. There's a very famous randomized experiment. It's one of the most famous in criminology in 1981-82, and it was very well done. It's by a guy named Lawrence Sherman, who's a professor at Cambridge, who's sort of probably the leading guy in the world on randomized experiments in criminology. Maybe there's someone in the room who actually is or something, but he's one of the leading guys in the field. So it's a very well done experiment. And what they were testing is when the police arrive at a scene of alleged domestic violence, which in 99% of cases is basically a guy hitting his wife or his partner. The traditional remedy is you send the guy away for 8 hours for a cooling off period and say, if I see you back here again, then I'm going to arrest you. And what they tested is they randomized police responses to these things into 3 possible responses. One is that. The second is mandatory arrest. And a third was to give advice to counsel both parties. And what they discovered is, in fact, there was a statistically significant lower rate of repeat calls for domestic violence for the mandatory arrest group. It just did much better than the alternatives. And status quo was basically send the guy away for cooling off period. So they improved versus status quo. It was pretty impressive. Over the next 10 years, mandatory arrest became the standard practice in most large police jurisdictions in the United States. At the time they published the results, the very careful researcher said, you know, you really ought to run some replications to make sure this is valid, right? Because we've only done it in one place.
Size of the original study?
It was hundreds. It was sufficient sample size. The internal there were no threats to internal validity. It was a well-done study, right? But their point was, like, this is in Minneapolis in one particular time period, et cetera. Like, you ought to be careful about this. So as it was being rolled out, they actually did researchers ran a bunch of replications. So you have the original Minneapolis experiment, change in repeat arrest, test versus control, negative, you halved the rearrest rate. And it was obviously statistically significant. Awesome, right? So they replicated a bunch of times. So green light is I basically had statistically significant beneficial effect. So it actually worked again in an Omaha test. It failed in Charlotte and Omaha, and it had no distinguishable effects in Colorado Springs, Miami, and Milwaukee. It's a distribution, all centered maybe a little bit to the left of 0, right? And the point is, when I run a polio vaccine trial, if I replicate it a bunch of times, it works every time, right? In a social policy experiment, even when I'm running experiments, I'm not even at this theory building stage, I run an experiment, the experiment is not some canonical measurement of the effect of this thing, it's a draw from a distribution. The distribution is always out there. I only see it if I run a bunch of experiments. You see this over and over and over again. It's extremely difficult to get anything which works in any significant fraction of subcases. And almost nothing, there are a few exceptions, almost nothing works in the vast majority of some cases. So if you think about it, this idea, as I said before, of what we call one-time moonshot tests, let's settle the debate around this effect, is totally misguided. It's a game of finding this little advantage here, this little advantage there, this little advantage there. So some summary observations now from, which will sound very much like the business ones from public policy. About 90% of new ideas, when we come up with these great new programs, we research them, we think them through, come up with them, we should assume as Bayesians, it doesn't work. Because 90% of prior smart people who came up with smart programs after a lot of work, they weren't just, tossing out ideas, 90% of them do not stand up to experimental testing. When they do work, just like in business, same thing, small improvements. And almost all improvements are conditional, meaning like what we saw with mandatory arrest or domestic violence. Right? And again, there are exceptions to every one of these rules, but they are very good rules of thumb. An observation is generally programs that try and change incentives work better than trying to counsel people into being different kinds of people or changing character. Last point I'd make, and this is more of just a comment rather than an actual finding. So there are lots of programs which you can't test as a practical matter. The stimulus thing I started with, unless you are emperor of the world and you can randomly assign countries to different stimulus policies, you're just not going to run an experiment, right? But no experimental evidence doesn't mean, in my opinion, I should assume, well, just because I don't have experimental evidence, this doesn't apply to me. I'm probably right. No, you're probably wrong, right? Because the reason you can't run the experiment is it's even more complicated than the things you can run experiments on, and those theories almost never work. So in other words, what this calls for, in my opinion, is at the base level, deep humility about our ability to outsmart current methods of organization. Not do it. I think we should invest in it and try and prove, but we should be very humble about our theories being correct. So the last slide is, I just say there are 5 kinds of things I would say. My observation of this data is non-experimental social science is not currently capable of making useful, reliable, non-obvious predictions for the effects of most proposed interventions. Second, very likely can improve its practical utility by conducting many, many more experiments and should do that. Third, even with such improvements, most real practical questions we face are going to be outside its ability to make useful, reliable, non-obvious predictions for interventions. I think recognition of this uncertainty calls for reliance on unstructured trial and error, the free play of society, the open society, this is Hayek and so on, right? It actually calls for a strong degree of reliance on that kind of informal or tacit knowledge evolved through trial and error. And last, and this actually goes back to one of the earlier questions, the limits to that, the limits to let's just let it rip. Let's therefore, since we don't know as much, let's have a completely, basically libertarian view of the world, in my view, are ultimately driven by the need for coherence, strategy, solidarity, long-term vision. So that's a kind of quick run through of a lot of what's in the book, and I think some of the themes in the article that was distributed earlier.
Very interesting, yes. Very interesting and very entertaining.
Good, well, I'm glad.
Yeah. Well, I just have a comment, kind of, and I enjoyed reading the article before the talk, and the talk was very good. But I just can't help but think that, perhaps the problem with social science and this kind of predictivity problem is not necessarily one of lack of experimental, lack of experiments, but it's kind of one of like the fundamental differences, I think, between like the hard sciences and the social sciences. For example, like with physics, and you bring up the law of gravity. Like you have a law of gravity. You have like a base background idea from which you can then present hypotheses and test them and then run them and then go back to your original law and see how you can adjust it. And I think an interesting example of this was like after when we started examining
faster than light.
Yeah, well, and like when we started examining things below the subatomic level, and I'm an anthropologist, so if the experimental physicist wants to correct me
I'm
on
going to
that point.
contend with that.
Yeah.
Well, but so we discovered that our understanding of like the law of gravity doesn't apply to this scale, and so then we run a couple of experiments, and that's how we find out. The idea, we didn't then just run a bunch of experiments and then kind of look at the data. We ran the experiments, my understanding, then evaluated what those experiments said, came up with a hypothetical model, and then ran them again.
Yes.
So we're kind of going back and forth between experiments and this kind of like baseline understanding.
Yeah.
The problem is with the social sciences, we don't have that baseline understanding.
Yeah.
And so I wonder if the emphasis might be more useful to try to create some kind of baseline understanding rather than just running a million experiments. I mean, the way I kind of see it is like a Greek geometer to discover the area of a parabola would just use the box method. you know,
Yep.
increasingly smaller boxes, and you come up with the error. Now we use the calculus. You know,
Yep.
it's kind of like same,
Yep.
same kind of idea. So I just was wondering. If you-
So up till the very last sentence prior to the geometry part,
Yeah.
could not agree more. And if it was a failure to communicate, if that wasn't communicated. So I think that, oh, sorry, I need to go backwards. So the point of these slides, this is just super slow. The point of these set of slides back there is exactly the point. I'm totally aligned with it, right? It is not, and it's in a business why you need strategies. It's not just like, let's just try everything. You don't make, as a practical matter, I spent a lot of time in the book, as an epistemological matter, you make faster progress with, strongly stated, weakly held theories that bundle together in a coherent way that are theories, right? So check. Second, I think that it's not, quote unquote, the problem of social science isn't the social science, it's the phenomenon, right? It's just way more complicated. And I think as you think about this description here, the way I think about this, sorry. The way I think about this chart I walked you through is essentially you can think of science as a method as this incredibly powerful wave that loses power as it climbs this hill of complexity. And if we could have such laws, this is the only point of distinction, if we could have such laws, that would be fantastic. And I'm not saying that we shouldn't be investing resources trying to develop them. My only point is as a practical matter, as someone who's a user of the output, we just don't have them yet. And so at the moment, we should try and extract the value we can, which requires us to be very humble about running lots of little experiments. That's not to say we shouldn't also be trying to build laws. They're not there yet.
Can I make a brief comment on this? I actually totally disagree with you, because if you look at how gravity was developed, it started out with the Danish astronomer Tycho Brahe, who took extensive observations of positions of stars, but didn't really do anything with it. Then Johannes Kepler comes along and comes up with what's Kepler's law, which basically talks about the rates at which they sweep certain areas in the sky. And that actually is a consequence, and Newton came along from that and actually developed a theory of gravity completely empirically and said that this only works out if, for instance, the gravitational force is proportional to the square of the distance of the masses and whatever. So there actually wasn't an idea to begin with. And so actually it makes a stronger point, I think, for what you're saying.
Well, I wasn't necessarily saying you just came up with it. I understand there's experimental evidence, but I think the distinction was that somebody moved from this kind of establishing a scientific worldview. It was a scientific worldview that was established that involved the law of gravity.
Yeah, but I would also, you could argue that in a way they were data mining the sky, right? In a very simple way that, when they first started taking these careful observations. So actually my question for you is, isn't this all kind of maybe just a limitation of statistics, in the sense that you're talking about hundreds of people, whereas in chemistry, right, it's a trillion atoms. Any law that you make is tested on, 20 orders of magnitude more. So like your error bars basically collapse, and you can really see quantitative trends much more clearly. So it seems to me that we should be taking this and scaling it up by 1,000,000 times and just running, once you start running trials that are involving billions of people, then I think you might actually see some laws about human behavior. I mean, if you think about it epistemologically, maybe it isn't that complicated.
Yeah, I think that's...
So I think it very strongly supports what you're saying.
Yeah, I think that you can think about the units of analysis for a given experiment. So lots of experiments do have millions of participants, for sure. Like lots of online experiments have millions of participants. There are, to take super simple examples, there are only so many stores in the world if you're running experiments on stores. So that's what the sample size is going to be dictated by the population. I think that the spirit of what you just said is that the way you kind of get there is not so much you're running experiments on many, many, many levels of abstraction, some of which are, you only have 27 markets in the US, some of which you have 10,000 stores, some of which you have 6 billion people, and so on. And so it's not so much you're going to get all the way down to people in every experiment you run on independent people, but you're going to get to many. I agree that we should have tens of thousands of social experiments running in the United States. And I think it's a totally realistic goal.
Yeah, and policy-wise, I mean, why do people actually make, I mean, I think this sort of screams to me like somebody like Obama standing up making promises that this policy is going to fix X. There's just no basis for this claim whatsoever. Not that it's deterministically wrong, but I mean, why,
Right.
is there some, like, can you push us forward into the policy realm, and should we start writing laws that everything is subject
Yep.
to a trial period before anything is implemented? No, because you have 6 people in some Federal Reserve Board saying, well, we're gonna
Right.
tweak this one number called the interest rate, and all of a sudden unemployment is gonna change. I mean, it's just absurd.
Yeah, I think that that's a huge topic and a very complicated one, and I think that the North Star you described, obviously, you're not going to get all the way there, but I've spent a lot of time in the last couple of weeks with people at the OMB and, folks who would be the people implementing such a system. There's a lot of appetite for piece parts of the system you just described. Yes?
I want to try to understand just how bad the red writing is in the bottom right-hand corner. I mean, when you present it this way, moving left to right, it's like physics, then biology, but then as we get to social behavior, then it goes haywire. But in a way, I mean, scientists are human beings,
Yeah.
men and women. It doesn't really go like that, right? It starts with human beings. It's supposed to end with human beings. I mean, how bad is the fallout? So here's like 2 ways of putting it. On the one hand, are you saying most political scientists in this department are completely wasting their time?
I'm not saying that in the slightest. No, I'm not, and I'm not just saying that to be
Isn't that
If they're not,
no.
run trials
No.
across political
if
departments?
they're not doing these controlled experiments,
No,
there's
I did
only
not.
1,000, but there's been many more APSR articles.
Yeah, right. I think that, I believe the following things. One is, I believe theory building and theory testing are both extremely useful activities. Second, I think that not everyone has to spend their time testing theories, and lots of theories can't be tested. I think there are whole areas of the study of politics and government that are probably not subjected to experimentation. That doesn't mean people shouldn't be studying them, and it doesn't mean they should not be trying to put the degree of rigor that they can by making those quantitative where appropriate. I don't think any of that's a waste of time, in the slightest. What I do think is, as a consumer of the output, as a decision maker who has to say, I wanted to execute this policy or vote for it or whatever, or not. When I'm presented with the argument I'm a president of the United States, say. One is the president of the United States. And I am considering actions for an emerging Iranian nuclear program. And my science advisor comes in and says, look, if they get this much fissile material and they compress it in a sphere of this size at this rate under the following procedures, it will explode with an explosion big enough to blow up a city. Thank you. Then a policy advisor comes in and says, our study of Iranian history says if we attempt to thwart this by changing the government, we believe that the people will just continue to change governments. I'm making all this up until they're able to get a government that gets this accomplished, that will be futile, right? I believe the president would be incredibly irresponsible to start debating physics with the physics advisor. Because first of all, if I really push him, I'm like, well, let me just show you the films of when you do this, it blows up every time. I think the president would be extremely irresponsible not to debate things with a historian, right? To say, well, let's get some other historians in the room, and let me talk to people who aren't historians who've worked in Iran, and let me see what they have to say. Let me think about me and my motivations, right? So I guess the question is, when my economics or political science advisor comes in the room, do I think of their advice more like the physicist's advice or more like the historian's advice? And my argument is, if they are not experimentally validated claims, it might superficially, if my economics advisor comes in and says, yes, the CIA is thinking about doing a counterfeiting program which is going to add this much currency, and we think this will convert to this much inflation over the next 3 years. And the president says, well, really, how do you know that's true? Her response is going to sound superficially a lot like the physicist, right? It's going to be a lot of math and equations and so on. But my point is, at a deeper level, it is much more like the historians if they're making claims that are not experimentally validated. That would be the way I'd answer that.
Just to follow up on this, on the president and his 2 advisors, so political philosophers, Machiavelli and Aristotle, they say they roughly group the world into the people who can reason themselves directly, and then most people who have enough reason to listen to good advice and understand what is presented to them as good advice. But a prince or a political leader, in the end, can't really be the second type. He or she has to make the call, and then we see that there are people in history who made really, really good calls, almost miraculously, and then there's a lot of people who made bad calls. How do you account for that brain power of the person who makes the right call? Because as you said, you can't run a natural experiment with the president of the United States. You just have to make a decision. There are people who can do much better at this than others.
Expertise is real, right? Non-scientific expertise is a real thing. It's very tricky, I think, often to distinguish skill from luck, in a market or an unconstrained environment. But there certainly is such a thing as expertise. What I'm describing here is authority, right? Not authority to order people around, but authority to say, this is the epistemological question. A physicist knows, not in an absolute sense, but knows at a practical engineering sense in a way that leads me to be able to rely on reliable, non-obvious predictions, that in a practical world I can rely on those, even though if you ask me in the absence of that someone with that technical knowledge, I would not think it was true, I can rely on it.
Bulletin atomic scientist is considered traditionally left wing.
So there's a big issue of what is the appropriate scope of expertise. Just because somebody has a PhD in physics does not mean their view on how to deal with the Soviet Union was a great idea. And so experimentally validated findings are one thing. And my point is, it's not that the economist or political scientist, it's not them as a person, it's that they do not have experimentally validated results to rely on. That's all I'm trying to say. And that's just, it's a different kind of expertise. It's not the historian, like, you should not make a decision without talking to historians. You just treat them differently than physicists. Right, someone was asking a question over here.
Actually, well, I'll
Yeah.
come back to what I was thinking about, which was, I was interested in why most social science experiments have such a low possibility for improvement over the status quo. Is that a function of the complexity, or?
I can only give you some speculation about that. I can tell you the empirical fact is most programs do not improve over the status quo. Why that is, I think, is the system is so complicated, or Bacon has this great quote, I don't remember exactly, but it's like the mysteries of the world are greater than our consciousness. That, the phenomena is so complicated, it's very difficult for us to develop improvements.
Even over something like finding the vaccine for polio.
Yes.
It's just that many orders.
That's my view, yeah. I mean, I can't prove that
Yeah.
that is the reason why, but I sort of think that.
One source of the complexity might be that in the human sciences, if there are any experiment is the object of the experiment reacts to the experiment.
That's right.
So if you wanted to ask whether a human being falls as fast as a cannonball, you couldn't trot the human being and the cannonball up the top of the Leaning Tower of Pisa.
Yeah, that's right.
And drop the two of them. So people resist being ordered around.
Yeah.
Even if it's more rational, or perhaps especially.
Yeah, right. I think it's true. There are several levels to that. I mean, one is just literally designing experiments. It can seem ludicrous the lengths you go to blind experiments, but this is part of the reason why. But then at a much, I think, more profound level, at a yet more profound level, there's this concept of randomization bias. Like, the people you can get to ever participate in these experiments are not representative of all the people in the world, and therefore it's a generalization problem. It's another generalization problem. And there is a yet more profound, I think, version of what you're saying, which is, in business, this expression, when you find a finding through a test, ice cream melts. Meaning, as soon as I've discovered this opportunity, the world's changing on me because people are reacting to the environment, and the opportunity to execute the business program, make more money in that case, is going away the day I discover it. So just because something worked in an experiment, when I start to scale it up and people start to see it and the world's changing, people are changing on me all the time, and part of that is reactions to the actions taken as a result of the experiment. That's right. That's part of what makes the system so complicated.
Well, I mean, I think that would be one of the problems with lacking fundamental laws.
Exactly.
Because you had the fundamental laws, then you would know how to, I mean.
Then it would be like physics. But
well, and it would be, this is an example, I think, of like the Lind experiment. In the sense you could say Lind's experiment with vitamin C was luck. Because there is potential that he would not have had any of the treatments involving vitamin C. Yeah, right. Because he didn't know how the system operated. So he couldn't make a rational, I mean, maybe, I don't know the details, but in theory, he could have not made the correct rational choice of the variety of treatments.
I mean,
and he would have just missed out.
That's right. To be practical about it, the way most actual pharma experiments work today, I have some target substance some target molecule that I want to act on, and you have this array of thousands to millions of chemicals. You go bang, 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 and see, it's like Thomas Edison. How do I find a long-burning filament for a light bulb? He tried like 15,000 substances. And so when you have weak theory, you get experiments to be cheap enough, and you run lots of experiments, getting lucky by being, systematic about searching as much space as you can.
If I could add another level of difficulty. We're assuming that we're running social experiments with the same treatment.
Right.
And you had your list of why this policy didn't work the same in Colorado Springs as it worked in Minnesota. But it strikes me another difficulty is having a uniform treatment is often extremely difficult. Trying to think about education. if you say, well, let's try things in a lot of different schools, and you might try something in a charter school where
Right.
you have very engaged teachers, and then you try to scale it up in a public school, and the treatment's going to be a lot different.
Yeah, that's right. So I go way down the rabbit hole on this question in the book. One of the reasons it's a small elite group of people who've actually read the book. But if you think about it, take the vaccine experiment. What I actually know is, even if I ran the experiment correctly, is when this list of people with these names who were wearing this color shirt on that day injected someone exactly this way at 10:08 a.m. in the following, there's an infinitely long list of descriptors which describe the treatment. And we know those will not be perfectly replicated in rollout, right? And as a practical matter, however, when I'm injecting a chemical into your bloodstream, I can specify enough parameters around it so that it's a competent nurse or doctor injecting this quantity in the right, and so on. So that, practically speaking, as an engineer, I can replicate it close enough, right? Closely enough. And so when you get to a social experiment, it's a very well taken point, which is it is often hard to control that implementation enough so it's done consistently. And then what you say, it happens in business all the time too, what you say is you want the same kind of variation in the test that you're executing in rollout. So you don't, in drug trials, there's this concept of efficacy versus effectiveness. Efficacy is treatment effect under ideal clinical conditions. Effectiveness is actual effectiveness in the field. And one of the points I make is in a social experiment, there is no such distinction. It is only effectiveness. So it's one of the reasons why when you run an experiment, when you do it correctly, you want to run it, say, in 10 different cities with a wide variety of different contexts and settings so that you have the best chance you can of getting good replicability. So there are things you can do to ameliorate it, but the problem never goes away entirely. It's yet one of the more of the problems. Yes?
So on these themes, I'm about 2/3 of the way through the book, really enjoying it on so many levels. This notion of causal density that you're talking about, I think is very rich from social sciences. And the source of some of that in human relations has to do with what you might call material complexities. I mean, you could take it on the genetic level of there's so much variation, also variation in weather, time, geography, whatnot. And those are things that are clearly can be solved by bigger data, and better statistics. And it seems to me some other people around the table have gotten at is there's this other aspect of structure in human behavior which comes from something like ideas. And culture, and you talk, I know, in the end of the book, which I'm not completely through, the way in which norms and cohesion might set parameters for allowing a lot of the other stuff you see take place. But I'm curious in the way you ended the talk of talking about incentives versus norms, and it's in changing incentives that you see a lot of the kind of low-hanging fruit in this. But it strikes me as one of the more kind of long-lasting, durable things, which often hard to control for, but play out enormously importantly over time, is actually what you might call the idea structure or cultural structure, where I know very well why certain things work in India that don't work here, that have nothing to do with material conditions,
Right.
Except if you want to call education from pre-neonatal.
I'm with you, right.
Material. So I was curious. I haven't gotten to the finish, but is there more that needs to be said about the way in which norms, the formation of ideas, end up fitting into how you think about developing the kind of social progress that actually complements experimentation in the way you lay out?
I'd say that the quickest version of it is that evolution of social norms is almost certainly not testable because it takes so long, it would be so complicated to test as a practical matter, you couldn't do it. Therefore, it's a product of kind of unstructured trial and error and competition, and that the only ultimate answer there is paradigm competition. I spent a lot of time in this book, and there's kind of hierarchies of paradigms, and that eventually, basically, people in Utah think it's really great to have lots of kids and so on, and people in, I don't know, wherever, Alaska or something don't. Oh, yeah, Manhattan. There's a package of behaviors and attitudes and so on that over time, one group's going to win and one group's going to lose. And you can't in a scientific way decide which of those are correct or incorrect. One's just going to win and one's going to lose. It's a frustrating answer, but I just think there's so much you can't ever really test. So much of the book is people got upset. Some people got upset because it seems like I'm cheerleading for randomized experiments. What I'm saying is you have to have them, right? They're necessary, not sufficient condition for this kind of knowledge we're looking for. But actually, when you look at how they're applied, and I'm doing it. I spent 15 years putting in tools to do this. It creates real value, but you can't take the model of physics and you can't take the model of the FDA and biology to apply to this. It's much more complicated. The benefits you get are more tactical, they're more limited, they're more focused, but you have to accept the limits of your knowledge, your limits to your knowledge. You know, the beginning of wisdom is recognizing what we don't know, kind of thing. Yes.
Given that randomized field trials have been around for a while, why haven't they been used more in public policy? And is there something that's changed recently that makes it more likely that they will be in the next 5, 10 years? Or is it just that you feel people haven't been pushing for them enough?
I think there are some things that have changed. One is, and I go through some of this in the book. One is just technology makes it cheaper, much cheaper. It creates a latent capability to lower the cost per test dramatically, and that's starting to happen. The famous negative income tax experiments, which are huge randomized trials, cost about $100 million to run a test. By the trials of the late 80s, early 90s, that was down to about $2 million a test. I mean, we have customers running tests for a couple $1,000 a test, right? So one is just technology, which is always the kind of secular change in modern society. Another is, I think there's been an intellectual acceptance on a weighted average basis. This is a gross overgeneralization, but the social sciences experimentalists in general and overall have tended to move from this, I believe, broken idea of the one-time moonshot experiment to lots and lots of experiments. So there's been intellectual progress in the field. And third, I think in the Anglophone world, there is broader acceptance of this by policymakers, and that's not broader acceptance of this. So, you know, you see enabling legislation that has happened in the United States. There's a big NAS report in 1998 that said this really, no kidding, is the gold standard evidence. You had enabling legislation in 2000 to 2002. In the Department of Education, by example, the creation of the Institute of Education Sciences, which has invested a lot of money and, you know, created percentage increase, doesn't matter because it's basically zero before that, are now running dozens to hundreds of education trials. So I think all those three things have come together, and we're making some progress. And if you track, you know, percent of articles that are experimental, not experimental, and percentage of prizes in those fields that are experimentalists, they're all rising. They have been rising steadily. Yes?
So I wonder if part of this is also the sort of culture or sociology of the fields themselves. So like in physics, it seems like in all these social experiments, nobody's ever wrong, or they don't want to admit that they're wrong, and that, oh, well, my theory is just more complicated, blah, blah, blah. In physics, right, you can make all kinds of predictions, but usually if somebody does a clear experiment, even if 90% of the people are wrong, everybody kind of moves on. Whereas, like, you look at these economic examples, right, there's no way you would have half the Nobel laureates in physics claiming one thing and half claiming the opposite, and
right.
not having half of them be discredited. Right?
Yeah. I think that is.
Look at this, and it's just like, come on, people. Like, somebody's got to be right here.
Yeah, I think that you're not giving them enough credit. I think that the subject they're studying is so complicated, it's difficult to reach that resolution. So let me give you a practical example.
But aren't they overreaching in the certainty of their conclusions?
Some of them are, yes. That's why I was quoting those guys. Yes, I think that is true. I think that, you know, I was in this business meeting, right? And it was this guy, he's a genius. He was a self-made billionaire who'd founded a series of highly successful retail chains. And he was doing testing long before we got there. And we sold him basically the technology to make it work a lot better and more accurately and so on. So they were in a series, it was a retail, they were in a series of experiments on changing window designs, you know, like at Macy's and stuff, you know, the Christmas windows and all that stuff. So conventional wisdom is it really matters what's in your window, gets people into the store. They're in a series of experiments where they'd spend money on making it nicer and cooler designs. And over, I don't know, a couple of years, they'd run probably a dozen of these experiments, you know, and the chief marketing officer said, you know, I made this observation, like it always fails. You know, the better window just doesn't do any better. So they had this meeting, and I was there with the CEO, and they said, look, we've drawn this really non-obvious, valuable conclusion. All this money spent on Windows is a waste. We should cut way back on spending on money on Windows. Because look, 12 experiments, we've proven it. The guys who say the Windows work are wrong. The guy listened to them very politely and said, my theory is your designers suck. Right? so the problem is, it's complicated enough that you actually, my program just wasn't done right. There is no way to experimentally disprove that, because you always can say, well, it's new designers. Now you need to go to Bolivia to get your designers, right? I mean, or. And so this is why a strategy and coherence is actually so important. So I think that I don't want to be interpreted as kind of attacking social scientists. I'm not. I'm just simply saying we need to, as consumers of the output, we need to understand how complicated the field is, and therefore how unreliable a lot of it is. So someone has got a chance to talk.
Following up on the software, there was a company called Lotus 123 who developed the spreadsheet, and then imitators came along. One I recall, Twin, another one called Excel.
Yep.
I assume that these comments that you have in terms of limitations with respect to social policy would similarly be applicable to business strategy, that you couldn't run an experiment to determine that Twin wasn't going to present any threat to you, but that this Excel out in the West Coast was.
Right. I have a couple chapters in the book about that, actually, yeah. Not that exact example, but basically talking about this in business and basically and laying out why it is that that's true. That that's not just kind of the guys in business are dumb or whatever. It's kind of inherent to the phenomenon that that is true, that you have to have strategic decision-making that must, in fact, remain, going back to something I said earlier, it must be intuitive. You must have, it can only not be non-experimental, it has to be non-analytical. You must make intuitive judgments. It's inherent to the problem. So yes, I believe that is exactly true.
So this is a slightly different question, although I would say that, actually, in response to this, I haven't read many experimentations, that's not the kind of social science that I do, but I have actually read a number of different people's ethnographies, particularly. You'll say, I went into this field site expecting this thing, and I was going to write on this thing, and all of a sudden I found that it was the exact opposite of what I thought it was, and so these are the results of my ethnographic research. So I have, in my experience at least, I've seen a lot of people who admitted that their initial hypotheses didn't work out, or hypothesis didn't work out. But my question more directly would be, so what would you have to say about, and you kind of briefly touched on this, about other kind of what I would consider to be kind of like the social science, empirical, kind of traditional research methods. And what I'm thinking of is I'm an anthropologist, and I'm one of the last structuralists, I think, around. But, you know, particularly in the 50s and 60s, there were these huge cross-cultural experiments where people would go out and they would, say, find, you know, their group of people from the source of their study, and they would, you know, look at how they categorize the taxonomy of plants.
Yep.
And attempt to determine how they organize knowledge like that, or give them various items and have them rearrange it to determine whether, you know, they were focusing on color or shape, or, you know, trying to look at some of these basic cognitive categories. So now how do you see that as kind of fitting into this framework? Does it have a role? Does it not have a role? Like, what?
Yeah, I think it sits on the theory building side of the ledger, and that ultimately what I'm talking about running experiments on are that will be turned into, and it might be 250 years before it's turned into, but it is ultimately turned into a proposal for some intervention. As a result of this and this and this and whatever process, a mix of analytical and intuitive process we want to go through, I'll make this example up. We propose that if we went in and, you know, taught people better plant taxonomy in the following culture, their farming output would improve and they'd be healthier and better off. That's the thing that would be tested. That's what I'd say. So everything you described is on the theory building side of the ledger, and just, I don't know anything about structural anthropology, but I'm presuming that's a valid way to build theories.
Clear question. You said that decision-making at the strategic level has to be intuitive and not analytical.
It has to include intuitive elements, yeah.
What is, I mean, the CEO who said the designers probably suck.
Yeah.
I mean, is that an intuitive or an analytical judgment? Because he's probably had tons of business meetings where we just can't do it, and he's like, you guys just aren't good enough. That's why you can't do it. So that's a typical businessman's response rather than an intuitive, I mean, or maybe not. I mean, can you give an example of a non-analytic intuitive?
I think that, you know, everyone's intuition is informed by experience. So what I mean by intuitive, non-analytical is think of an informed historian making a judgment using facts, knowledge, stories, theories about the world, and drawing a conclusion which is not an output of regression analysis or something like that, and is not experimentally grounded. Exactly. It's kind of, I've had experiences in life, I've seen things, I've listened to these people, you know, it's inherently squishy. It cannot be turned into an algorithm, would be the best way to put it.
You used a phrase at the end of your remarks, you rushed through it and sneaked it in, so to speak, in a libertarian world.
Right.
What is that?
Well, in the book, what I say is, you know, the last third of the book, I basically end this second section, which is all about this social policy, like it's really hard to do anything stuff, and say, you know, the obvious political observation here is, the obvious conclusion to draw is, we don't know nearly as much as we think we do. We can't rationally control. Like our theories of rational control, really, when push comes to shove, they don't demonstrate, I mean, gross exaggeration, don't demonstrate improvement, or at least our knowledge is so limited, that if our knowledge is limited, we should structure things to allow evolutionary competition, through trial and error to make progress. Like it's glacial and painful and statistical, but it's better than the alternative of no progress or anti-progress, because we're trying to rationally control things we don't understand. And what I say is, that's great. And if I were a Martian observing the Earth and had no attachments or commitments, that's exactly what I would say. But the fact is, we are attached and committed to our families, to our society. We care about not this protozoa beats that protozoa, but like I live in that protozoa, and I value, I live in France. As you see this there right now, they're not idiots, right? I mean, we need to compete in a globalized world, but there are things they love about France. There's like the baguettes really are the best, right? Like it really is great, and there are great things about that society. So, what I'm telling you, there's this balance that has, or not balance, but there's competing interests, which is on one hand, what I say is in an evolutionary environment, the only rational person is a sociopath who is skilled at feigning empathy. But we don't just want ourselves and our families and our societies to win. We want them, and survive by that I mean, we want them to survive in a way that retains the essence of what they really are. And that's the whole last third of the book is about, well, how do you think about that? How do you think about the fact that I care about this society I live in succeeding, but also not becoming something totally different than it is in order to succeed? And that's kind of what I was talking about. The natural, I think, simplistic straight line conclusion from this is, well, we ought to just minimize laws in every possible way, let jurisdictions compete, let everyone do what they want. And I give the example of, suppose I live in one state and I learn that in some distant state they reinstitute orphanages for kids. Okay. And then I learn that they institute corporal punishment for 5-year-olds who steal. And then I learn that they begin executing 8-year-olds who steal. And I say that as a practical part of the hypothetical, none of these kids who survive this are going to come into where I live and bother me. There's no practical effect on me. But at a certain point, I recoil from it, right? I don't want to be in political association with people who would act that way. It's attacking my identity. And so that's sort of the sort of little story for, well, okay, how do we think about this? In a totally libertarian world, in the most extreme sense, I'd say, well, let 1,000 flowers bloom and we'll see who wins. But I don't want that to happen, right? And so that's what I mean about there are limits to, I talk about this idea of 3 limits to liberty and so on. What are the limiting constraints or factors on, if I recognize how ignorant I am, why not just let everyone do what they want, and in grossly simplified terms?
Here's a question in education between 2 schools of thought. One which says that education works best when when a strong sense of formal authority prevails, and the other which says the opposite, that it works best when there's a democratic willingness of teachers to listen to children and to let them teach themselves. Now, if it's true that rapid iterative testing is a necessity, and if it's only going to lead to small or gradual reform, would it ever be the case that one of those 2 schools would want to give it up and surrender to the other? Or isn't this, so to speak, what we have now? That is, with ignorance plus loads of social science studies on either side of any question, gender, abortion, and whatever.
Yes. First of all, first order approximation is exactly what we have now. And when I talk about these conclusions at the end, and I'll page through as I'm talking about, these conclusions at the end, I think the improvements, if the world executes, if I were emperor of the universe and it executed exactly what I'm recommending, I'm promising marginal improvements. I'm promising, on the margin, you could get a little bit better for certain kinds of decisions.
Yeah.
That's all.
Well,
And
there isn't any margin in a case like this. There's just 2 opposite schools.
There are many decisions that are never, potential interventions that are just not testable. And I think that, that one almost certainly, first of all, you'd have to decide what's success, because one group might just define success differently, and that's one of the reasons they wouldn't give up. And another thing is that you almost certainly have certain populations where on any given metric of success, one's going to work better than others, and so on. you know, is there something that formal testing can do to accelerate that learning process? Yeah, probably on a little bit. You know, two worlds. I have a good rapid iterative testing capability, exactly the same world, but I don't have it. Would world A make more rapid progress in refining those two points of view and getting them to some places more? Yeah, probably, but it's not going to be night and day, no. And I think it's important to understand that, like, and I don't think it's that there's this other way to improve social science that I haven't thought about that somehow is going to make all that work. I don't. All I have to offer the world is a way to make things a little bit better. It's just what I say is a small % improvement of 300 million people and $15 trillion is a lot.
Now, the postmodern people would say that science itself is a point of view.
Right.
And it's postmodernity, or postmodernism, that's the point of view of the point of view.
Right.
So that's what they want to stress. And they could say, as against these...
They can stop using modern technology and go back living in a cave. They don't think science works. Fine with me.
Well,
you know, you're going to tweet that? It's like, okay, science doesn't work. How did that happen?
I think...
Well, maybe it doesn't work, but I was going to give some examples of, to bring together the two things that were said about anthropology and physics. The Mayans had these priests who watched the skies at night closely, making observations over years and years, and writing them down, looking for eclipses and so on. But they never used this knowledge of nature's regularity to suppose or to conclude that it was unnecessary to propitiate the gods in order for human beings to live successfully. So the point of view of modern science seems to be that it's unnecessary to propitiate the gods,
right.
if you like. So you're going to ask a question like, as you did, but still it would seem that before you get to modern science, you have to raise that first.
I agree with that entirely.
Yeah.
So first of all, one of the things I read in the book is science is just a point of view. And it has to compete in a Darwinian process with other points of view. It's just, as you say, it wins, right? And so in the end, and I spent a lot of time up front trying to lay this out, there is no, science provides no absolute frame of reference by which to judge the assumptions of science. It is judged by the broader society through whatever method we use to judge it. And the fact is, in the end, it creates such material benefits on the back end that it works. It works in that sense, at least, right? And that's why we fund it so much.
It works because it teaches people to think that it works.
Well, I don't...
And that, for example, that it's better to live longer.
Well, what I would say is this, you know, it provides capabilities, right? It provides capabilities. And I think it works because, like, there really is a device here which can store information and I can pull it back up. And it doesn't, I get the point that that will shape how I think and it might, you know, propagandize me and make it easy to propagandize me that I really care about that. I get that point. But I think in the end, societies that aren't able to exploit that technical capability just get beaten by those who can, or at least up till now. And in the end, if it turns out in the very long scope of history that actually in the long run it would have been better not to have done that because these other societies will win, then they're going to win. And then we'll learn science is not as adaptive as we thought it was. But science can't tell us that. That's not a scientific point of view. I think the other thing that's very relevant to what you said is the Baconian transformation and how to view science is critical. And it's not science really until, I mean, there were people doing it, but he systematized this. And it's very difficult to exaggerate, in my opinion, the importance of he had a number of conceptual revolutions, but one of them is, you know, the purpose, this is not me quoting him, but my view of it, the purpose of science is improved engineering. It's not truth. Science does not seek truth. It seeks improved engineering capability. And he's very subtle about scientists can't believe that. Like he talks about this. Scientists must believe they are the sons of knowledge. But in fact, the real purpose is to increase the ambit of the power and greatness of man, right? And he was very subtle about if you focus only on creating these improvements, you actually won't make so much progress. You need experiments of light and experiments of fruit and so on. So he was extremely subtle, in my view, about how he thought about that. But that is a crucial distinction between proto-scientific traditions and actual science as was invented in the West. Yes?
I have a question about replicability within all these trials that your company and companies like yours are running. So you put on the board the number 90% fail rate, right? So 10 to 20% of your experiments are coming up with, are having their hypotheses validated.
Yep.
For how long do those hypotheses tend to hold up? Like, I mean, I can imagine, you know, Target runs a vast number of experiments and realizes that it makes more money, you know, on items that are visible at eye level, until maybe people figure out that they're being targeted by having items put at eye level
Yep.
that the company
Yep.
wants to sell to them.
So
how many of those hold up over time? And I just want to throw in, since I have it in mind, since I saw that you quoted in your book from the realm of medical experimentation, that article by John Ioannidis, Why Most Published Research Findings Fail, from Journal of the American Medical Association a few years ago. And I thought that was connected to this question too.
yeah, it is. So I think that, you know, the sustainability of effects is the phrase, once again, is ice cream melts, right? So all effects are deteriorating as soon as you find them. Some only last, I guess in theory, some last days, but I've never seen that. You know, things last weeks and months. Sometimes it's just a seasonal effect. It's only going to work around Christmas time or back to school or whatever. Other effects persist for years and years and years. And so what you're doing is you're running what we call pinging. So you develop your theory, you test it. You then, when you execute the test, when you execute the program that you tested, you're trying to hold out a random subsample of whatever your system is, customers, stores, territories, whatever, so that you're constantly running a control against it to actually measure where you see that deterioration. And so some things are quick and some things are long, and as long as you have the capacity to know, I'm starting to lose the benefit and pull back out, that's how you take advantage of it.
Well,
I think sorry?
Well, I was just going to say, I think one of the important parts about the point of social laws, cognitive laws, would be that I think some effects would never change. Like the eye level example, there's no reason to think, I mean, you would have to basically remind yourself every time you're in a store, every time you're looking at something, that I'm being manipulated by things that are at my eye level.
Yeah, I mean, a good example of what you're
That
saying.
happens to me every time I go in the store.
Yeah, never generalize for yourself. So there's a famous example of this, which is a very valuable piece of real estate in a store is 3 steps in and to the right, because actually when people walk into a store, a high proportion of them will take 3 steps and look to the right. And you know, that doesn't mean it's going to last forever. It doesn't mean it works in every context, but it works in most contexts pretty consistently, and has for many, many years. So there's a lot of things like that.
Well, even more fundamentally, I think you could look at like the postmodern movement within literature to break out of the narrative, right? You can't do it. You constantly come back to a narrative when you try to write a non-narrative story.
Right.
So I mean, there are certain rules like that,
Right.
that you just, no matter how hard you try to get away from them,
Right.
you cannot operate outside of those bounds
Right.
of thought.
Isn't that an absolute law of human behavior then?
Yeah, right.
Well, no, I would argue that this would be the structuralist position. That's the first principle of human thought, and that's why you can't operate outside of it. Is that it is the principle from which all thought originates.
It doesn't matter what it is,
Yeah.
I'm saying, but doesn't that then argue that there does exist a fundamental principle of human behavior as with sort of more or less the certainty of a fundamental law of physics, such that certain behaviors should then be predictable and testable, and that should come out no matter how you decide to test.
Yeah. So, and there are some such things.
Yeah.
You know, and what I'm saying is the laws of theory, right? And then the question is, what interventions can I build? And there are interventions you can build, like I put this instead of that at this location. And then what you're competing with is not, I'm an idiot, but you're competing with people who've run stores for a long time, and they're kind of aware of this, right? So your intervention is now competing with the status quo, right? Which is, guys run stores and they know that's kind of a good spot to put good stuff.
The status quo sort of represents some stability. Some point
Well,
of stability
it's a trial and error process. You're part of the way through an evolutionary process, right? I think that the 2005 paper you're referencing is a very interesting one, because the headline result is, what the guy did, it was a very influential, extremely influential paper. He went and looked at, I forget the numbers, 40, 50, 60, something like that. It may have been fewer than 100, maybe closer to 100. Several dozen of the most widely cited medical research papers. And for occasions where such a widely cited medical research paper was then attempted to be replicated. And what it basically is more than half of them either failed replication, or the effect of the treatment was substantially lower than what the effect was in the original analysis. What I get to in the book is, what sits below the headline is, if you divide those initial influential studies that were replicated into 2 groups, randomized clinical trials of the drug and all other types, 90% of the randomized trials were fully replicated, right? When they attempted to replicate it, 80% of the anything else was not replicated. So the success rate here was 90%. The success rate here was 20%. And that is in, in my view, a less complicated topic, non-experimental results, they're just not as reliable.
Some medical research you cannot run randomized trials.
Yeah, that's right. There are many, many questions. That's right. You can't do it.
Orphan diseases or for many of the
Exactly.
late-stage diseases, you simply cannot have randomized trials.
Yeah, that's right.
You have to shot in the dark.
That's right. And so what?
Those trials should never have been lumped together. I mean, those research papers. I mean,
That's
like a crate of bananas and a crate of apples. You
Right.
just kind of put those together.
That was my point in the book, that you have to think about these two categories separately. Yeah, no, definitely. And, I think that, once again, and I have a section on does smoking cause lung cancer, right, where at least for a long time there are no randomized trials. There are many topics on which we are never going to run experiments, right?
Because we humanly
Yeah, you can't do it.
There's a Harvard committee that will prohibit doing that.
Yeah, I mean, there's IRB problems, and for macroeconomics, you can't run a stimulus experiment, again, unless you could randomly assign countries, right? So there's just many questions you're not going to run experiments on, and we should do our best to develop the knowledge we can about it. But the only point I'd make about that is, in those areas, we shouldn't assume that these methods, which don't work really very well when you test them against randomized trials, are somehow going to work infinitely better in these other areas. Like, we should be cautious about our certainty of knowledge. We should be humble about how much we know about those topics, that's all. Yes?
I can sort of imagine the kind of conversations you would have with your clients and the ones who are receptive, making the decisions that they would make.
Yeah.
But I was wondering if you could talk a little bit about conversations you've had with the Paul Krugmans of the world and how they respond to your critique.
Well, I've never talked to Paul Krugman, so I couldn't say about that specific example. But I think that there's a reform movement inside these highly quantitative social sciences, and I don't feel like I'm a voice crying in the wilderness on it. I think that particularly younger researchers in economics and the very quantitative sciences, there's a cohort of those people who are very focused on experiments, and I think that at a conceptual level, you'll always get head nodding when really push comes to shove, and so should you do this or that? There's definitely a generational divide. But I would say, among younger, leading, quantitative social scientists, there's a big cohort of experimentalists. So I think there's change happening in the field. Yes? Sure.
I was just going to ask a follow-up question based on your answer. So is there, in thinking about whether the effects that you think, whether theories that you think you tentatively validated decline in their efficacy over time at varying rates and varying degrees, is that, when you say that, do you just mean that the profitability of those strategies is decreasing over time because other companies are doing the same thing, and therefore once everyone discovers the 3 steps in into the right rule, it becomes less effective as a strategy for making profit? Or are you saying that there is I suppose it could be both of these, is there a difference in the replicability of the results that you think that you're finding and that medical drug manufacturers are able to find?
Both. I think findings about interventions in social behavior are inherently less stable, I think, than chemical injections into the bloodstream. And there are many possible causes, not just competitor reaction, but the environment generally will change on you in a social setting like business, and that those two are probably very related. Part of the reason why it's not so stable is it's so dependent on these context factors, which inherently are varying in lots of ways.
Well, we have to stop, and we want to thank you again.
Great. Thank you very much. Thanks for your attention.